All right, in this video, what we're going to do is we're actually going to find all the rational zeros. All right. So in the previous video, we learned how to list all the possible ones by using the P over Q method. We're going to do that again. Once we list them all, then we're going to use synthetic division or substitution, whatever, to actually find the ones that are actually zeros. So I have a couple examples that we're going to use for this. All right, so first of all, let's look at example 1. Here I have a polynomial of degree 3. So that means I have 3 possible zeros. All right. But what I need to do first is I need to find all possible. I need to find all possible ones first. All right. So we do P. So P is 8. So the factors of 8 are 1, 2, 4, and 8. Q, the leading coefficient, which is just 1. So that makes that nice. So the factors of 1 are just 1. So now I'll list them as fractions, as ratios. So I'm going to do 1 over 1, which is 1. 2 over 1, which is 2. 4 over 1, which is 4. And 8 over 1, which is 8. So I listed all possible ones. So there's 2, 4, 6, 8. There's 8 possible total, but only 3 will work. A maximum of 3 can only work. That's if they're all rational, right? They could be imaginary, irrational. All right, so let's go ahead. Now we're going to set up synthetic division. So we got 1, 5, 2, and negative 8. And we get to pick which ones. I like to start with this one, because it seems like we'll just start with that. Put 1 in. All right, and our goal is we want the last number to be 0. If the remainder is 0, then that value that I put in this box here is considered a 0 of the function. All right, so that's what our goal is. Our goal is we want this to be 0 down here. All right, so here we go. We got, bring down the first one, be 1, multiply, add, multiply, add, multiply. Well, that was nice. We got lucky. First one we tried, we got it. So 1, positive 1 is a 0. Okay, so we found 1. Now we want to find the other ones, if there are any. All right, now remember, I take the remaining 1. Now rewrite it. See, it's a degree of 3, so I decrease it. So now it becomes a degree of 2. So in other words, this right here becomes 1x squared. Or we can just say x squared. And then plus 6x plus 8. Set that equal to 0. Now since this is a quadratic, we can use the quadratic formula, or we can factor this by, or we can solve this by factoring. In this case, factoring would be the quicker way of doing it. So we got x, both be pluses. Factors of 8, that if I add will give me 6. That's 4 and 2. Set each one equal to 0. So x is equal to negative 4 and x is equal to negative 2. So my zeros are 1, negative 2, and negative 4. And there they are, and there's 3. All right. Let's try another example. Okay, here I have a degree of 5. So that means I can have up to 5 possible, no more than 5 zeros. So I can have no more than 5 zeros, whether rational or irrational or imaginary. I cannot have more than 5. All right. So what we're going to do is we're going to list all possible ones first. All right, so we do the P over Q method. So P is the constant, which is 2. Factors of 2 are 1 and 2. Q is the leading coefficient, which is 1. Factors of 1 are 1. So this is nice. So now we go ahead and do P over Q. So it'll be 1 over 1, which is 1, 2 over 1, which is 2. You notice here I only have 4 possible rational zeros. So that means there's no way I'm going to get 5. Because this right here, listing all possible, tells me I can only have up to 4 now. Well, let's see how many we actually have. So, use synthetic division. So it's a quintic. So the coefficient here is 1, -1, -2, -1, 1, and 2. All right, let's try +1. Remember, our goal is for the last one to be a 0. That's what our goal is. Right? And we just keep doing this whole process over and over. We do it for 1, -1, 2, and -2 until we find the ones that work. So bring down the first one. We multiply, add, multiply, add, multiply, add, multiply, add. So that's -2. Multiply, and it worked. We got lucky again. Sometimes I do some that almost I have to go 2 or 3 times, guessing 2 or 3 of them until I finally find the one that works. All right, so now this becomes, now it's a degree of 5, now this becomes a degree of 4. So this is 1x to the 4th plus 0x cubed minus 2x squared minus 3x minus 2. All right, so now if I rewrite this without the 0, so I have x to the 4th minus 2x squared minus 3x minus 2. You notice here I have a quartic. So that means I want to try one. All I have left now is -1, positive, and -2 I can try now. All right, so we set up the division again. All right, so let's try -1. So this time we have 1, 0, -2, -3, and -2. I'm not using the original one because we don't need to anymore. We decreased it by 1. All right, so we're going to try this again. And our goal is the last one to be a 0 again. So bring down, multiply, add, then multiply, multiply, multiply. All right, we got lucky again. Today's my lucky day. I might have to go to Atlantic City after school today. All right, so now -1 works. So now I have, now I decreased, this is a quartic, a degree of 4. Now I decreased it by 1, so this becomes x cubed minus x squared minus x minus 2. All right, still I can't factor this, so that means I gotta use this whole process again. All right, so I have x cubed minus x squared minus x minus 2. All right, and remember we have positive 2 left, positive -2 left to try. All right. So let's try a 2. So we got 1, -1, -1, -2. There again, our goal was to get 0 here. Bring down the first one, multiply, then we add, multiply, then we add, multiply. Definitely going to Atlantic City. All right, I'm 3 for 3. All right, so now we know 2 works. All right, so now we have, now we decrease it by another degree, so now we have x squared, 1x squared, plus 1x plus 1. Set that equal to 0. This is not factorable. So I have to use the quadratic formula in order to solve this. All right, so I found 3 rational zeros. This is a degree of 5. All right, so that means I can still have more answers. Okay. So now I'm going to